We are going to talk about solving radical equations. A radical equation is just an equation that has some sort of root in it or a power that's expressing a root. So these problems are similar to what you practiced last time. Notice that I've got some sort of root in here equals a number, and our x, our variable that we're trying to solve for, is under the root. So our goal is going to be to eliminate this root. Here, since I've got root x equals 8, I can eliminate that root right away by simply squaring both sides. The square and the square root will undo each other. Those are inverse operations, and since I square this side, I also have to square the other side. So I would get x equals 8 squared, and 8 squared I know is 64. So x equals 64 for this first problem. For our second problem, we're going to use the same idea. We have more things under the root this time, but I still have the square root of something equals a number. So to undo this square root, I'm going to square both sides. The square and the square root are inverse operations and undo each other. So I'm left with x minus 2 equals 3 squared, which is 9. And now I've got one more step to get x by itself. So I'll add 2 to both sides, and I get x equals 11. For our last introductory problem here, I don't have just a plain old root by itself. I've got 4 times a root. Anytime I have something else on the same side as a root, whether it's a number in front that I'm multiplying by, a number underneath that I'm dividing by, if I have the square root of x plus something or minus something, my first job is to get the root by itself. So if I'm adding something, I would have to subtract that thing to the other side. Here, where we're multiplying, that means we'll have to divide this number to the other side. My first step is to get the root by itself. So when I divide both sides by 4, I have my square root of x by itself. 20 divided by 4 gives me 5. And now I can square both sides to get x by itself. So square both sides. That will undo my root over here, and I get x equals 25. Again, notice that in each problem you had to get the root by itself before you can eliminate it by squaring both sides. We're going to continue to look at roots today, but we're going to include more than just square roots. So we can use this same process for other types of roots. Today we're going to look at cube roots, but you could do this with fourth roots, fifth roots, any index root would work. So same idea. I've got the cube root of x minus 4 equals 0. I want to solve for x, so my first step is to get the root by itself. I'm going to add 4 to both sides so that I have my cube root of x by itself and equal to 4. And now since I have a cube root, I can undo that with a cube. I want the index and the power to match in order for them to undo each other. And if I cube the left side, I also need to cube the right side. Then the cube and the cube root, since they're inverse operations, will undo each other, and I get x equals 4 cubed, which is 64. I need to remember to check for extraneous solutions, just like you had to check your rational functions for extraneous solutions. We need to check our radical functions for extraneous solutions. So to do that check, I'm going to take my solution and plug it back in for x in my original equation. So I would have the cube root of 64 minus 4 equals 0. And I want to simplify this and see if the left side is actually equal to the right side. So the cube root of 64 is 4. So right now I have 4 minus 4 is equal to 0. And 4 minus 4 is 0. So I know that the left side equals the right side, and my solution is a real solution for this example. We're going to do the same thing with part B. We need to start by getting our cube root by itself. So to do that, I'm going to divide both sides by 2, and that will eliminate this 2 in front here. That will reduce with the 1 on the bottom, and now all I have on the left-hand side is the cube root of x plus 1. And then on the right, 8 divided by 2 would give me 4. Now that I have a root on its own over here, I can undo this root by cubing, And if I cube one side, I have to cube the other. My cube and my root are inverse operations, so they undo each other. And I'm left with x plus 1 equals 4 cubed, which we know is 64. And now I have one more step to get x by itself. I need to subtract 1 from both sides. So I get x equals 63. Just like last time, we're going to check for an extraneous solution. So to do that, again, I'm going to plug my x back into my function and make sure that the left side equals the right side. So I would have 2 times the cube root of 63 plus 1 equals 8. So what I have is 2 times the cube root of 64 equals 8. The cube root of 64 is 4. So on the left side, I've got 2 times 4. On the right side, I've got 8. 2 times 4 is equal to 8. So again, my solution is a real solution.